Okay, this is a demonstration of Boyle's law. Now, Boyle's law is all about the volume and the pressure of a gas, an ideal gas. Now, these two things are not completely disconnected. One affects the other. If I change the volume, I'll change the pressure. And if I change the pressure, I'll change the volume. Now, we're going to test that today using this apparatus. You can see I've got a number of things set up here. I've got a bucket, and in the bucket I have a balloon. Now, this balloon is of known volume, right? In fact, we can work out the volume of the balloon by thinking about certain things, such as the diameter of the balloon. Now, we know that the volume of a sphere is 4/3 pi r cubed, don't we? Now, the radius in this sense is just half of the diameter, which we will call L. So, in this case, the volume, V, is equal to 4/3, what am I doing, pi, and then L over 2 cubed. So we can work out the volume quite simply. Now, if the volume changes, now what we can do is we can take a new reading of L from this ruler here, and this will give us a different value for the volume. So we have a way of measuring the volume. Now, in real life, this round balloon essentially fills the shape of the container that it's in when it's put under some pressure. So, as an extension to this project, you might want to think about, rather than measuring volume in terms of a sphere, measure the volume of a cylinder. And as the length of the cylinder decreases, then so does the volume. Okay, so how do we work out the pressure? Well, what we do is we get this. It's a lid with a ruler in it and a pen. Now, we're going to place this on here, and we're going to put some masses on it to weigh it down. And we put them on each side so that the masses are all equal. And what this will do is it will start to compress the balloon like this. Now, how much pressure is that balloon under? Well, it's all to do with the amount of force that is acting upon it. If you remember that pressure is force per unit area, then we can work out this, that pressure is force per unit area. Now, the force acting in this case is the weight of those masses. Now, each one of these is 100 grams. So how do we work out the weight of 100 grams? Well, we must multiply it by the gravitational field strength, G. So what it becomes is the force is equal to mg. What about the area? Well, what is the area? Well, it's a circle. It's pressing down on a circle of known radius. So what I would do is I would measure the radius of this circle, and I would therefore know the area over which this was acting, because the area of a circle is pi r squared. So pi r squared. And what I can do is I can add more and more masses as time goes on, like this. 1, 2, 3, 4. And 4 more. One, 2, 3, 4. And what you can see is there's a definite change in volume. As the pressure is rising, the volume is decreasing. Now, as an experiment, what you need to do is to be able to measure for a given pressure, what is the volume? And if you've done it correctly, you should see that as pressure decreases, as the pressure increases, the volume decreases, and it should be a 1-to-1 ratio. If you don't see this, then you need to start thinking about reasons why. Why is it that this experiment does not perfectly represent Boyle's law? I'll leave it up to you.